All right, that said, this is a hello world file in Mercury. Can everyone see it okay? I'm working this out too. All right, the syntax is definitely weird unless you're coming from Prolog. Mercury syntax is a direct subset or superset of Prolog syntax with a lot more declarations that are supported, as well as custom infix operators if you want them. Like most of Prolog, you end up defining rules, and your program is evaluated by solving those rules versus defining functional computation. So it's a little different than Haskell because Haskell is so oriented around functions that you end up with data processing, where Mercury is focused mostly around rules. So in terms of the syntax, anything that starts with a parenthesis or a percentage mark, that's a comment. And you'll see those peppered throughout sections to divide them because some rules can get fairly long. Anything starting with this little 2-character operator right here, which is called a horn, is a declaration. They're simply used to provide information to the compiler and don't have any functionality on their own. Anything of a form that looks like this, where you have a name and then parentheses, that is a rule. Defining rules is how you define a program. Rules can have horn glosses after them too, which have a series of dependent rules, or goals that follow them, which look like rules and can evaluate to false. The horn is actually pronounced if. So you can read this main function as main io1 io if print hello world io1 io. Now, what's a little strange about here is these io values. Mercury is actually a pure language, a lot like Haskell. But unlike Haskell, it doesn't try to encapsulate io into a monad. It exposes that state value that Haskell implicitly passes around in the monad. What is also different about Mercury is that Mercury has full-blown unique types. After you use something that is marked in the type signature, which begins with pred or func, as a destructive input, which DI is short for, it cannot be used again. So it is actually an error for me, and the compiler will complain if I duplicate this. Because io1 is still live. You need to destroy all unique outputs, or destroy all unique inputs and return all unique outputs in order for a program to be correct. It's very similar, actually, to the type system in Rust, which uses references. Mercury's are still just normal types, and in fact, you can lift any type to these unique types without them being references, and borrowing is not an issue anymore because you don't deal with raw references. But Mercury's been doing this for a long time, along with some other research languages like Clean. Anyway, so the only problem with doing this is dealing with IO type, like these new variables that get created over and over could be, oh God, I'm sorry for this. My computer broke this morning and I had to go out and buy a new one. This keyboard is bizarre to me. My physically broke at 9 a.m. this morning. So I spent all morning running around trying to fix it. So if you have syntax like this, it can get really annoying to keep naming these IO variables. Mercury actually has special syntax for this. If you prefix, whoa, that escape key is not where I expect it. If you I should be fine in a minute. I mean, that'd be great, but also unlikely. So if you prefix a variable with IO or the exclamation point like IO here, it actually expands at compile time into 2 variables and keeps creating unique ones all the way through. So you can do something that kind of resembles a state monad in Haskell, but with raw Prolog semantics. You're actually creating new variables and destroying them with every single iteration. So if we, for instance, if you are wondering how to run this and you are, I guess Codio is not working for anyone. So if you're wondering how to run this, I've built out a make file where you can do run example 0. Permission denied. I know I have a backup file, but I don't know why it's there.
Does Codio not run?
If you are trial users can't run terminal commands, and there's no way to compile it really without that. So if you are on Codio, you can definitely edit the code and mess around with it. You're not going to get anything out of that, really, though. You can, if you buy it, you can absolutely compile, and it'll work just fine. It's $15. I don't think I'm the only person using Codio, but I've not been to any other sessions today, at least. Let me try deleting that cache file. There we go. So it prints hello world twice. Super easy. Definitely foreign, though. These declarations are required in any exported types, which main is always required if you're writing an executable. And they all these declarations start with the word pred, and then the name of the functor you're defining. And functor is not used in the Haskell sense. Functor is just the name of any rule. So the functor of main is main2, like main with RD2 here. I'm going to use that a lot. Don't get thrown off by it. It has nothing to do with mapping or variance or anything like that. But you start with pred as the first item, the functor name, and then all of the arguments types. This is actually shorthand for a different thing. So main has this as its actual type signature, which is required to be exported here. It also has a mode, which is unique as far as I can tell to Mercury, which is how it defines how a evaluation of a rule is done. So if I have main with di and uo, it means that there is a destructive input on the first argument, and the second argument is returned as a unique output, and it's also deterministic. What's really, really neat about Mercury, and we'll get into this a bit later, is I can also have something like pred. We'll do the standard family that everyone is used to in Prolog. If we have like parent as a functor, we'll give it two arguments, a parent and a child. And we have, I don't know, Alice is Bob's parent. Bob is, I don't know, what's the name that begins with C? Carol, great. Great, we have all those. So if we define parent with the predicate declaration, takes two strings. We can define multiple modes for it, and these determine how it evaluates. So if I were to provide a parent name, I can get a child name semi-deterministically, which is inferred. It is non-det, actually, because we can get multiple branch sets. So we can get it non-deterministically, ignore what I previously said. So we can actually get all of the children for a single parent and keep evaluating them automatically. This is a lot like the list monad. Anytime that I then access a child that gets returned from this, it is implicitly flat mapped, I guess, into the rule. And that's a little complicated to explain, so I'm just going to keep typing for a bit and define some more modes, and then we'll actually run this and see what it does. Likewise, I can go backwards. Given any, this should be not, it can be non-det, but we're not going to make it non-det. So given any child name, we can get a parent name out as well. And this is complaining because technically with what I've defined, it's semi-deterministic. If I provide any child's name, I'm not going to get more than one parent back. But it's technically correct to say it's not deterministic because of the semantics of it. There are two more modes we can actually define for this that are legal. We can ask for all of everything, and it'll give it to us if we want. We can also ask if someone is a parent to someone else, and this one is fully semi-deterministic. There are actually a lot of these determinism modes, and they form a lattice. I'm not going to go into all of them. But the basic ones you'll see most often are deterministic, failure, multi-deterministic, which is multi, and non-deterministic, which is non-det. And without writing any more code, we've actually defined four different functions in code. Every single mode expands to a different definition in the underlying engine. So I'll be using the C engine for all of this just because it's the fastest. But there's also Erlang and JVM backends if you're interested. Yeah, it's really neat. You're only required to implement a few primitives too, so it's pretty easy to write one of these backends. And there are backends without garbage collection, and it works just fine. As long as you don't use the FFI, Mercury is actually able to run with just a stack. It's less ergonomic in some respects, but a very interesting language. So what we can do is actually, let's ask who Bob's children are. So if we do this, oh God, please just work how I want you to. There we go. This symbol is kind of like the if statement in other languages. What comes after this will only be evaluated if this is true. And then you add a semicolon after to say or. You can add that without the if statement, but still just trying to give introductory information. So if we can bind some child to Bob, let's just print out the child. Otherwise, we'll do nothing. We'll get an error that this is not allowed. Yeah, that's fine. It's true. It's there. The problem is actually, despite the awful error that my compiler is reporting that it can't find the symbol, the problem is that child can be more than one thing, and we declared up here that main is deterministic. What happens is if you have a rule that calls another rule, the weakest determinism becomes the determinism of that rule. But we can actually collect all of the results, and collecting results is fully deterministic. So we're going to import a module called solutions, and that's in the standard library. In the channel, there's actually a link to the documentation for the standard library. It's huge and hard to navigate. I apologize for that, even though I did not do it. We can actually say children. No, we'll not do solutions for define an inline predicate. So we'll say the solutions for the predicate parent. Whoop. We'll assign this to the variable children. And then we will print children. And just quit there. So, no more underlines. We're good. Open up this, make run ex0. We can see that the children are Carol and Dan. It collects all the results for us and just returns them in the list. There's a few of these solutions predicates that return sets or unordered lists, or actually let you fold through the solutions as they become available. These are all primitives in the language. I can't really show how they're defined, but they work, and they're basically necessary. And that's the basic gist of Mercury itself. I don't expect anyone to be writing programs at this point. I actually have other example modules that may give more of an idea of how things are actually used. So if we open the first example, which is FizzBuzz, if you don't know what FizzBuzz is, which...
Just a quick question.
Yeah, absolutely. So by default, Mercury only will ever assume one determinism or one mode for any predicate or function, and it tries to make the determinism declaration as strong as possible. So it'll try as hard as it can to infer a determinate or a deterministic mode. Every time you enumerate another mode, it tells the compiler, okay, generate the code for this function as well automatically, so you don't have to do anything. But you do have to go and specify all of them. Otherwise, it'll just tell you that that's not right. It's a little bit unfortunate because it gets real verbose, and I think the example after this one actually has a very verbose one. So if you are on your own machine and are able to compile and run, you can actually try this yourself browsing through it. I'm going to walk through it in front of everyone because I know some of us can't run things right now. But you can actually test the results of any of these with, instead of make run, make test. And it's going to complain at me. Basically, main is already defined, and there are input and output files, and make will just fail if there's a difference between them. All right, so FizzBuzz. Yeah, it's a loud language. The nice part is that you don't have to define a lot of code. You're mostly writing signatures. It's like if Haskell is taken to the extreme in that case, which is nice and also bad. If you don't know what oh yeah?
So for the mode, defining the mode and the determinism of it, what does that purchase you, I guess?
It lets functions be run backward or forward.
Right, but I mean, I'm fairly familiar with like sweep or log or whatever.
Mm-hmm.
I mean, the modes are there, but they're not strictly defined. Like you can run it forward or backwards and just regular stuff.
Got it. So the question is, why do we have these modes at all when Prolog doesn't have them, essentially? And the reason is that Mercury is strongly typed, and it has a type system on par with Haskell 98, including existential types and type classes and a whole bunch of nonsense that's built into this. Modes are included in this because, like Haskell, which determines things like inlining from type signatures and function bodies, Mercury actually determines the function body from the modes. So deterministic modes, for instance, don't require Mercury to place backtracking points in the function, but a determinist or a non-deterministic one will. And non-deterministic also has to take into account error cases, or semi-deterministic. So it just allows the compiler to optimize the code as much as possible. And it also allows you to define an interface that forbids certain usage of predicates, which you don't really get in Prolog. You can try to unify anything. Yeah? Yeah, actually. So a semi-deterministic function is a partial function, and deterministic is total. It gets a little hairier when you get into the non-deterministic modes because traditional functions don't exhibit more than one output for any input. If you wrap it in a monad, yes, but the function is still only returning one output, then a list of things, instead of multiple individual values, which Mercury tends to do. All right, FizzBuzz. If you don't know what it is, it's a simple test that's often given as an interview question to weed out people that have never coded before. Its actual value in that is debatable, but the rule of it is if I give you an integer and that integer is divisible by 3, you have to output fizz to standard out. If it's divisible by 5, you output the word buzz, and if it's divisible by both, you output both, and neither, you output the number itself. So I figured it'd be a good way to show how to write more realistic functions in Mercury. These aren't super real world, but it gives you a pretty good idea of what an actual mathematic library, as simple as it is, looks like in Mercury itself. So I'm actually using all these modules. Import is how we pull in another module unqualified. It merges the namespace with the current namespace. Use, it forces you to qualify the module name before you use any predicates in it. So it's very much like import qualified versus import in Haskell. There is no way to narrow the list of things that are imported, which is a little bit unfortunate, and it's actually frustrated me a lot, but Mercury supports overloading. So if there's more than one function name, it'll try both, unless it can't determine which one it is. So here's the code, and I actually left a to-do error right here for those that want to attempt this on your own. But my general idea in tackling this was to create a type of the results rather than passing out strings. And this enumerates the 3 things that we can actually return, given any number, either FizzBuzz or the number wrapped in some new type. This is exactly like the data the data keyword in Haskell, except instead of pipes, you have the disjunction operator, which is the colon instead of equals. You have this weird long arrow. So we have three types, two fizz and buzz take no arguments, and one n does take an int. And then other than that, all we have is a way to turn that into a string. So if we were to tackle this, we'd want to, first of all, make these real arguments and have the compiler complain at us. We actually just have to define all the rules that are possible. So one of the situations I mentioned is if the number I is divisible by 3, we need to output fizz. And really, to execute this, instead of pattern matching or writing if statements, we just say I rem3 is 0. The comma, which means and you use it to separate statements. Here, FizzBuzz, our output, is fizz. We have an alternative situation. I rem5 is 0. So this is if I is divisible by 5, we output buzz. Super easy. Otherwise, we need to output something else. So this is where it gets tricky. So if we do not I rem3 equals 0, if we approach it this way, the compiler is actually going to complain at us a lot. Display errors. I don't use that shortcut enough. Yeah, it's going to be annoying. Oh, Emacs. There we go. So it thinks that this function is non-deterministic, and a unification with one of these three disjunctions, one of these three OR statements, can fail, and it's not true. We have a total situation where all three of these cases they cover all possible inputs. This is unfortunately a shortcoming in the mode inference, and you can overcome it by using that error that I used in the last module. So if we group these two things, these two disjunctions, that I rem3 is 0 and I rem5 is 0, and instead of using the semicolon, we use this. Oh God, my indentation is broken. And rename this to FB1. I'll explain why in a second. Then we unify this. Otherwise, we unify this. Like Prolog, the error... I got a little carried away with the parens. Why are we angry? Yeah, either way, I'll deal with that in a second. Like Prolog, what this does is if this evaluates true, Mercury will no longer try to evaluate this part of the disjunction. Normally, when you use an OR operator in Mercury, it's not an exclusive OR. It doesn't mean this or that. You could have both. So ORing two deterministic clauses that aren't mutually exclusive actually gives you a multi-deterministic result, because you can have more than one result and will. So you need to actually tell Mercury not to go down and execute both parts of the disjunction, because they are distinct in our logic. Okay, and then it says in line 39. We also don't need that not statement anymore, because this actually implies it. Oh, thank you. Once again, keyboard, new computer. So, as you can see, it's now compiled just fine. And we can actually test this with good old... And I've actually just generated a huge file of random numbers and run it through this and checked it with another program. You can find those in the test directory. And we can see that this now compiles just fine without the error. It gets rough when you're doing things that are destructive inputs, because you have to handle all cases and you end up with a lot of nested disjunctions. But we can go over the actual I/O that this is doing as well. When we enter the main, we grab all the arguments, and that actually is a custom function, LC LambdaConf. that reads them from standard in if they're available, or the command line arguments and returns them as a list. Otherwise, errors. If we do have all the if we have no arguments, we die right away and exit 1. Otherwise, we fold, an effectful fold with this IO. It works a lot like just using mconcat on a state monad. But our types are actually explicit. We can fold print over it. Otherwise, we die again because we can't parse it as integers, which we do in the map function. All right, that was a lot really quick. Does anyone have any questions? It's a little harder trying to accommodate people that can't compile, but...
Yeah, I can't run the big file.
Oh. There is another, on Mac OS, the default make is BSD make, and I didn't try to run it with BSD make. If you install GNU make and run it against that, it should run fine. Apparently there's no undefined directive in BSD make, that's an extension. So that's what's going on there.
There was a comment on Slack with the install command for, but you don't need to substitute it, just use the button. Your USL local seller.
All the errors are largely harmless as well. They're C compiler errors. This version of Mercury, the latest stable one, was released in 2014, and the compiler has changed a lot since then, and those are mostly deprecation warnings. The nightlies don't throw those and haven't for years, but unfortunately the nightlies you'll have to compile yourself, and that takes a good long amount of time. Is there anything that's strange about this syntax or what's actually happening? Why we're actually able to assign this variable to a result twice?
Some things like Prolog, like I recognize some of the Prolog.
So this right here is a non-deterministic result, because you can unify with either the first or second or neither.
That's like a list of 2 different answers?
Yes, and it's a possibly empty list, basically. When you use this operator, though, the little arrow followed by the semicolon directly after it, it actually says, if this has at least one solution, then do this. Otherwise, do this. So it separates trying to evaluate all the disjunctions and instead works like an if statement.
Is this the multi-mode that allows it to resolve both?
Yeah, so it's multi-deterministic. It can return as many answers for FB as it wants here, as long as there's one.
So how do you get there's an and product for 15?
So remember that solutions? Mercury, if you define a predicate with only one mode, you can actually curry, just like Haskell. So I ask in this print FizzBuzz for all the solutions, all of the solutions for the I that I input as
Solution and buzz is the solution.
exactly. So we get a list back with all the solutions. It actually turns it directly into a list at that point.
It prints out pass space. Well, it should be pass.
So I'm not exactly sure why it does that, because these are canonical types, and by default, Mercury derives EQ and ORD, basically, for all types. By making them, I don't know why the first predicate, unlike Haskell, or the first constructor, unlike Haskell, seems to be a larger value. I didn't spend enough time to run it, but reversing it fixes it and gets it out in the right direction. It's a little annoying, but what are you going to do? Yeah, exactly. The order's not guaranteed anyway. Well, it is for solutions, but do it returns.
I'm just trying to just find out, like, how did you come to Mercury, or like what sort of, the Prolog people and your Haskell people, so why would someone come to Mercury?
So I programmed Haskell professionally for about 4 years, and there's a lot left to be desired in terms of how well it works. Namely, when you're doing business logic-y things, most of what you're doing is actually just if statements over and over again, or something in the either monad. Prolog is really, really nice for that. It's really great to just list a bunch of rules and then be done with it. Like, not worry about monads or anything. My problem with Prolog was that I don't love non-pure languages. I love being able to control I/O and see where I/O is happening. And Prolog has a whole bunch of these predicates which are a little bit strange in that they actually perform effects. And there's other declarations that you can say if they can be evaluated more than once. It just kind of struck me as weird. I found Mercury about 2 years ago and kind of just fell in love with it despite how verbose it is. It's really, really nice to be able to like list rules as if they're rules, but not have to deal with monad transformers and wrapping and unwrapping and classes like monad base. And I mean, the type system is very nice, especially combined with the mode system. You actually have things that are somewhat like quotient types. You can say, like, for all lists that are non-empty, this is deterministic, but it's multi-deterministic otherwise. Like, you can do things like that. I'm not going to get into it because it gets complicated really quickly. Maybe if we have enough time, I can drop into that. But it's honestly, it's a very good compromise between what you get from a language like Haskell and what you get from a language like Prolog. Huh?
Curry? Have you looked at Curry?
I haven't actually.
The language code.
Yeah.
I was looking at that.
I haven't, but I've heard good things.
Quick question related to something that was brought up earlier with reverse.
Yeah. Mm-hmm.
Whether I have reverse or I don't, I get BuzzFizz.
Or you don't?
Yep. When I just removed it and recompiled,
Oh, that's how we're getting BuzzFizz. There. Never mind. Strange. Gotta love non-deterministic code. What you can actually do there is write your own ordering function. There's a where clause that can be added to the end of types. So where comparison is, if I do something like this, I don't want to write the whole comparison function because it's too many cases. But for instance, I can say like FizzBuzz compare fizz. They're equal. And I can even shorten this using Prolog stuff to AA. You can pattern match with one variable twice and it makes sure that it can unify. Fizz B provided B fizz is less than everything else. So you can add rules like this. There's obviously a couple more cases, but you can go down it. Yeah?
You actually need to validate that these are this, because if they were the same, wouldn't they unify on the first one?
It would unify on both.
What would the result of that be, I guess?
So what you would get is the same, you'd get the same result set if you asked for it, but Mercury is unable to infer that they're separate without the cut if operator. So this is exactly equivalent to having like result A, B, and then defining, oh God, A equals B, res equals, like pattern matching in the head or unifying in the head is the same as just doing a normal disjunction. It expands to this, so you need the cut operator somewhere or the cut if operator. Otherwise it thinks that it's multi-deterministic when it's not. In fact, this might do that too. I haven't spent a lot of time with non-canonical types that aren't used through the FFI. All right, yes, that's weird. Any other questions? Sorry about the ordering thing. That's definitely strange.
it's interesting.
Yeah, I mean, multi-deterministic. Can't predict order. All right, I'm going to jump up to the third, or the second example, which is technically the third. I don't know why I numbered them that way, which is routing in HTTP. If anyone here is a professional programmer and you do anything with servers, you've dealt with routers that let you map both HTTP routes to functions and vice versa, so you can change routes and have them update in templates and such. And this is where Mercury really, really shines and why I like it so much as a language. If we define a whole bunch of types that define an HTTP request, and if you've never seen a raw HTTP request, which I would bet most of you have, I actually don't have it in this repo. It's on the Codio one. You end up with a path method, a bunch of headers, and a body, and that's it. It's just a bundle of data. If we go out and enumerate all these, so we have a method, a path, which is a list of strings representing just a bunch of slash delineated things, headers, which are just key value pairs, we can create a product type request, which just has all those things. Similarly, we can create a response, which is similar but does not have the method path and instead has a status using standard product types. We could also create equality types in Mercury, which works a lot like just type synonyms in Haskell. Anytime it sees hpred in this module, because it's not exported, it's in the implementation, it's going to unify that type with a predicate over a list of headers, a string, a response, and IO values. And we can also create instance synonyms, which I haven't gone over too much yet because this is where you get forbidding empty lists, for example. We can create an instance signature which says that the headers and the body have to be incoming, the response is a unique output, and IO is destructive input and unique output. And we expect a deterministic result from any handler that we give. Handlers themselves are a named hpred. So we can wrap up pointers to predicates in data types. Predicates are fully first class, provided they have at least one argument. Predicates without any arguments are optimized away, actually, at compile time and become an error in line. You can't take the address of them. It's unfortunate. And then, because predicates can't actually be unified, it results in a runtime error. I have to override equality for them. I wouldn't worry too much about what promise equivalent solutions is, but it's a mode cast. It has certain requirements, but any two handlers with the same name will treat them as equal even if predicates are different. Then we could do things like define handlers. Static variables are functions that don't take arguments. Mercury also supports functions, by the way. And we'll just name it the value of the current predicate along with the predicate index, and index will log out serving the index page and return a 200 with nothing on it. Could also do things like stateful requests using module mutable variables, which are safe. They get wrapped into mutex and require IO to modify, provided you attach to the IO state. So get logs is get logs, and we're just going to take up to 10 and return them separated by new lines in the body. Pudding, we're just going to add one to the head. So this takes a body, we get the old ones, set it to body plus the old ones, so it can append on forever. It's a huge memory leak, by the way. Make sure you print these if you ever use these, things like this to accumulate values over time. This is where it gets interesting, and this is the one predicate that I chose to leave undefined in this module. We could define a single function called route, or predicate called route, that has all of these different modes. That gives us fully bidirectional lookup and also partial lookup. We can provide it a path with no methods and get all of the methods and predicates out that path is valid for. The logic for this is actually really simple, and provided Codio worked, I wanted this to be kind of a gotcha, but the test expects these routes. And instead of, if you've done Prolog, this is fairly evident what you'll end up doing. The logic for this actually is just to declare a bunch of rules without any body whatsoever that match our requirements. So get empty list, index. That's a route. We can match against it and run the index if it matches. Route, get, index. Define them lots of times. And these are actually generating C functions that will unify these if necessary in all of these different directions, which is a huge amount. Likewise, we can get logs. And put logs. And it will fully type check at this point. And we can do things like get all of the routes using this function routes, or get a summary, which is a string. I'll go into that in a second. What's really neat about defining these modes, and it's the answer to another one of those questions, why do these exist when they aren't in Prolog? I cannot define ambiguous paths unless I define an ambiguous mode. So this, we have the same HTTP method and the same path, but a different predicate at the end. It actually violates this very first mode, which says if I provide it both the path and the method, I can get a handler out or a failure. With this logic, I can actually get two different handlers out, and it's a type error at the unification level, which makes it a lot more powerful than something like the list monad, because I can restrict it arbitrarily based on the inputs and outputs. You can get close in state and exactly the same with something like an index monad, but in Haskell, those are turning on overwritable syntax is a whole mess. We can keep adding to this forever until we come up with something that is, for instance, ambiguous. So that's fine. I can keep adding other names for logs, like log lines. If I could type, and it's just going to keep building up this routing table statically with bidirectional lookup for free, or for as free as you can get. If we want all the routes, and this is a good example of how to actually look these things up, we use solutions again. This comes up a lot when you want to turn anything that is non-deterministic or multi-deterministic into a deterministic result. So solution set gives us a set of all the things, which takes a predicate with a single output and just unifies it as many times as it can and inserts it into a set. So this gets us the entire routing table statically, because there are no arguments. It's evaluated as soon as it possibly can, and only once. You could also create a route summary, which just creates a plain text version of it, which is used for the testing in this. And then where it gets valuable is, let's say you're writing templates and you have URLs, and you want to be able to change the handler for them and still have your links redirect to the right page. You can use a predicate like URL, which just takes any handler, which are named, and returns the URL. Just by defining a function which takes a handler and outputs a URL. What's really interesting is CC non-det. Any of these determinism modes that start with CC are called committed choice, and it means that there's technically more than one correct answer, but we'll only ever pick one. So anytime you see CC, it has the semantics of a non-deterministic mode, but with the functionality of either a semi-deterministic or a deterministic mode. So this, sort of like cut. I don't know the semantics of cut when it comes to like reunifying variables. This, if you try to do this twice, there's no guarantee that like your outputs are going to unify later. And that's the only difference, is it guarantees like that you have a correct output if you get an output, but it's not going to try to guarantee that the output you got is the same as the one you got last time. It's a little more predictable. Cut lets you specify which one you're getting back. CC non-det does not, and neither does CC multi. It's going to give you a result back, and it'll be the first one it encounters successfully, which is back-end dependent. But you can't say, give me this result if I only want one, like you can with cut. You need the soft cut to do that with the arrow. This is really powerful, and this is where I grasp Mercury really well. Languages like Haskell are really, really good for computation. given this input, give me the next output, and reducing values into smaller and smaller sets. For relational computation, it's a lot more difficult to use. You end up with state or some kind of monad, and there's no nice way to define it without using like MTL, which I have issues with. This is readable by someone who doesn't know the language. If I say, just add a route, it's very easy to do without any context. I don't have to define any extra rules, but I can for how this is backed. There's no set of maps behind the scenes that is unifying all these things given some set of inputs. It's very, very straightforward, and I hate to use this word, but declarative, which is a lot of the goals of Prolog itself. But Prolog has problems like unification and equality are different concepts. Mercury doesn't have that issue. You can have two different variables and unify them so long as that they're equal. This is the one thing that I want y'all to take away from this, is how you can define relations so much easier than other languages. And with that, this is actually my last example that I programmed in, because what I'd really like to do is, for those of you that can, I'd like to work on parsing, because Prolog is really, really good at parsing. In the Codio ill-fated project, there is a example put request for working with logs. What I want to be able to do is create this request type out of an actual stringy HTTP request. And unfortunately, we'll have to go look up one of those if you're not familiar with the syntax. But if y'all don't mind some live programming, I think that would be a really good exercise to kind of show the other big strength of unification over a computational model. So let me go. I don't want to manually define. Whatever. We'll just. Someone tell me if I'm doing this wrong. Get path is it? Is someone familiar with HTTP? Is it method path HTTP version? The first line? I'm gonna have to look this up. Yeah. Oh, that'd be great. Just because everything's so small. I believe it's that. So, for instance, the index request could look. Is that right? Okay, awesome. Oh, well, it's not technically right because it's no carriage return. It's just a new line, Emacs. So if we were to, this is our simplest case, really. Uh-oh. It went away. There it is. And I suppose because everyone's not able to run this, we can walk through it together. But remember our state variables, which we used for I/O before? That actually comes in. It becomes very, very relevant with parsing as well, because most parsers are just a list of characters to a result, a list of results. So we could start just by defining some predicate that takes a list of characters. We'll just use characters as tokens. Returns a list of characters when it's done. And then also gives us an entire request back. I'll just define this as nothing right now. Great. Is this complaining about modes? No, cares is not imported. And you all have to excuse the live coding. I actually had this fully done, but not in the Git repo because that was accessible from Codio. So, hanging out on my dead computer, so we'll have to do this together. So we should start first. We should start first by looking at the first thing that we expect to come in on this list of characters, which is just a verb. So we have parse method or verb, and this is going to return a method. Do the same list chars. It's also not chars, is it? It's just char. And this one is pretty easy to define. Without having to write a body at all, we can write this. We'll take the space as well. There, we've just written a parser for the get method. And if we just duplicate this down for post, I forget all of them that I have. I know I don't have all of them. If we do this all the way down for get to post and for post to put, so there we go, nice and pretty. Without writing a single line of a body and just defining rules, we've actually written a parser for HTTP methods. And we can keep doing this all the way down. So parse path, a little more complicated because we have, it can repeat. This will give us a list of strings. No, thank you. To be honest, I'm not even sure if there's a regular expression library in the standard library, and the build tool is make for Mercury. There's no fun thing like stack or npm.
Do they not have DCGs?
Oh, they absolutely do. So the DCGs do not have regular expression support in Mercury. You can write a DCG, but there's no like literal for regexes. I mean, a DCG is a regular expression.
Well, it's stronger than that.
Is it?
If it has the variables, it's at least context free.
Okay. I believe that. But yeah, you can actually do DCGs. What he's asking is that there's a syntax in Prolog that looks kind of like this with an arrow. And this actually totally exists in Mercury, but outside of parsers, it's actually deprecated because it's exactly the same as using the state variable syntax. And in every line, binding a new state variable. They claim it's harder to read, and they might be right. I don't use it a lot. Who knows? I don't have a huge opinion on things like that. What? Yeah, I'm going to keep doing that. I'm good at it. Great. I can also just call it path because I defined a synonym. So we're not allowed to get an empty list here. It's invalid. But we can start with the base case, which is just a slash. So our path is an empty path if we just have a slash and then a space. It will pretend, although it's not exactly correct, that space is a reserved character in HTTP. And you can't just end up with one of these. These are going to complain at me up here too, because these are strings and not lists of characters. It's not like Haskell in that regard. Oh. Guess I'm doing this. There we go. All right. So this is our base case. We could say we have a path component or cursive. That's also not right. Okay, so if we have a slash and then a whole bunch of characters that are not slashes. So we're going to name this after, because why not? We can take while. I might have to open the documentation for this because Mercury names things interestingly. We can take while we have a character in equals, now we want a predicate. We just want character to not equal slash there, and character to not equal space. Once again, we're just kind of fudging it, pretending that spaces are reserved characters in HTTP, even though they're not. So that we have the after list, and what you end up with this is not what I want, because I want split. All right. Time to pull up the standard documentation. This is why I linked it. I type it in a lot. We want the documentation for a list, and we want something split. Ba-ba. Nope. Take. This is another bad part about Mercury is they don't use type classes for map even though they have them. There's a reason for that. They don't have higher kinded types. So you have to write crazy functional dependencies to get it to work, but there are 8,000 folds here. If someone else has found it, I don't know if anyone else is looking, that'd be great because there's like 4 characters on my screen at a time, as you can see.